Hello, my name is David and I'm very happy to present today the best tutorial you are going to see about installing Grafana and Prometheus. We are going to use a Helm chart to easily install Grafana and Prometheus. Moreover, we are going to install with a single command a Kubernetes cluster in our machine. In this case, we are going to install K3s, which is a lightweight distribution of the standard Kubernetes cluster. Because this version of Kubernetes is very lightweight, everybody can install the K3s cluster on their laptop or on a server, even if the hardware is very limited, for example, in a Raspberry Pi. We are also going to download and configure a node exporter dashboard in Grafana. With this dashboard, we are going to be able to see the consumption of the resources in our machine, such as the CPU percentage of use and memory RAM consumption, but also more advanced metrics such as swap memory used or context switches. So let's go to the slides to understand how this observability system that we are going to set up actually works under the hood. Here we have the diagram of our system. We can see how we are using the Ubuntu server machine and that we are going to install this K3's Kubernetes distribution cluster. And we are also going to have installed Helm. So what we basically do is to download the Helm chart from the Helm repository that is on the internet. You can see that the chart is called kube-prometheus-stack. And this chart is, as all the Helm charts, composed about templates and then also a values.yaml file. The templates are the Kubernetes resources that contain this Go templating language that is going to have these tags that are going to be then filled by the values.yaml file at the moment of doing the installation. It is important to notice how this kube-prometheus-stack chart, it is not the simple, the basic and simple example of Prometheus, but in this case, the templates or the chart is composed about an operator and also some other more simple resources, let's say. So the operator is the one that is defining the Prometheus installation itself. And in this case, we are also using Grafana to have the dashboards and a node exporter that will be the component that will make available the metrics from our server. So the operator is basically composed from CRDs and controllers. We are going to explain with more detail about the operator in Kubernetes in the next slide. But at this moment, you can just remember that inside of the CRDs, we are using a service monitor, which will make configurations for the Prometheus server. So basically what happens when we are installing the Helm chart. We install it with this Helm command, for example, and because this template is containing an operator, we are using in our K3's cluster one component that is called Operator Lifecycle Manager. This component will be in charge of deploying the part of the operator, and the rest of the parts from the chart are going to be deployed as a normal Kubernetes resource. So at the moment that everything is installed, we can just make a kubectl get pods and services, and we are going to see that it has translated all these CRDs and it has deployed also all these resources. And now we are seeing the typical pods and services in Prometheus. So now let's talk about the operators. The operators are one kind of component from the Kubernetes that allow to specify stateful applications. These applications are the ones that they are dependent on some state to be correctly working. For example, we can mention again Prometheus, which is the thing that we are deploying. And as you have seen, it is composed of different different resources. We have the Prometheus server, we have the Grafana charts, and so on. And everything has to be deployed in an order and taking into account some considerations. So, as we were mentioning, the operators are composed of CRDs and controllers. The CRDs, or custom resource definitions, are some files in which we define a personalized or a custom component in YAML. So instead of having the native components such as pods or services, we define our own resource. It can be a Prometheus server, a service monitor, and so on. And then to deploy these CRDs, we define what is called the controllers. The controllers will be the ones that will be checking that these CRDs are correctly deployed in our Kubernetes cluster. They will also be in charge of the logics of knowing how to deploy all the, let's say, resources of these operators. And yes, they contain these logics that know what to do in case of a failure. Other examples of operators can be, for example, for defining database clusters. Here I have put the MySQL operator or the Postgres operator. And it is also important to notice that if we want to develop our own operator, we have to use the operator SDK. Here we have to know that we can develop an operator by using Helm as the Prometheus chart, and we can also do it by programming in Go, or we can do it by using Ansible. Here it is just a quick reference to how does it look like when we are installing a Prometheus server. This is without taking into account if it's in Kubernetes or if it's in a local machine. We can see that the main component is the Prometheus server itself, that is using a time series database. And we typically have also Grafana in the same machine or in another machine. And the Grafana will use the PromQL to make the queries to the time series database of Prometheus. It is also important to notice how we have the Prometheus targets. And for each target that we have a component called exporter. This exporter is the component that is in charge of preparing all these metrics from the components to be ready to be pulled by the Prometheus server. Here we can see again how we have deployed all the resources related to the Prometheus. In this case, we can see all the deployed pods. With respect to the service monitors, as we have said, they define the additional targets for Prometheus to scrap, and they avoid touching Prometheus configurations directly and give you a declarative Kubernetes syntax to define the targets. Here we can see an example of how does it look like a service monitor. You can see that the service monitor is just pointing to a service, again, of our Kubernetes cluster. And the important thing is to specify in the selector one of the labels of the service that it is going to scrap. And here we can see how after we installed our Kubernetes operator from the Helm chart, this service monitor CRD got installed in the Kubernetes cluster. So here it is also very interesting that we can access to the artifact hub which contains the Helm charts. In this case, we have installed the kube-prometheus-stack chart. And it is also very interesting to see that we can access the template and the default values. If we go to the templates, we even have a searcher, a search bar in which we can put, for example, service monitor, and it is going to give you all the CRDs that are of type or kind service monitor, and you will be able to see how they are defined. Notice how the Go templating language is being used here. And we also can see the values.yaml for the default values. And we also can see here this operator hub. So remember that we are installing the Helm chart, which is composed about the Prometheus operator and other resources such as the Grafana dashboard. So in case we only wanted the Prometheus operator, we could just install the operator, and we can get more information about this operator in this operatorhub.io. As you have seen, this system that we are going to install is pretty complex inside, but we are going to make it really easy in our tutorial. We are going to install this couple of tools with a very few commands. Before going to the tutorial, let me present the sponsor of the channel, which is Datapta. Datapta is a consulting company specialized in big data, public cloud, and DevOps. Datapta has a team of experienced engineers who work with the best companies in the world to bring their tech projects to life. If you need to deal with big amounts of data, deploy your infrastructure on the cloud, or automate your deployments, you can email to info@datapta.com or just use their contact form. We are going to start with the tutorial now, and you can see that all the commands that we are going to use are available on the website davidprat.com. So you can access into this URL from here, and let's execute the first command. Here in the first step, we are going to install K3s and Helm. So the first thing that we are going to do is to create this couple of directories that we are going to use to store the snapshots and the backups of K3s. In this case, you can see how I already had done this command in my laptop. So this is the reason the directories were already created. And now we are going to proceed to make the installation of K3s. Here you can see how we are accessing to the website of K3s to download the Kubernetes distribution. And then we are going to execute the server command with the flag ---- cluster in it. And the ---- token flag, this token from here would be used in case we wanted to attach different nodes to the same cluster. We are also going to execute this command, write kubeconfig mode 644, which are the permissions that are required to operate with the kubeconfig file in K3s distribution. We are going to disable traffic in this case, because in case we wanted to interact with the internet by installing some website, we would be using Nginx ingress. And the rest of the flags that we can see here, they are intended to perform the snapshots and the backups. So now we are going to make use of this alias here, which is very useful when dealing with kubectl commands. So instead of having to invoke always kubectl, we can just type k. And then we are going to install Helm. In case you were with some CentOS machine, this command would be different. And in the second step, what we are going to do is to actually install Prometheus and Grafana. So the first thing that we have to do is to make a git clone of the repository. And in this case, we can see how the path is already there on my machine, because I already had done this. But once we have the repository cloned, the next thing that we are going to do is to add the Prometheus Helm chart repository. So we are going to make a Helm repo add, and then we are going to specify the repository. And after this, what we are going to do is to install the version of the chart that we want. In this case, I already had done it in the past, and because I was loading a backup, because K3S is able to do that for you, it was already there. The next thing that we are going to do is change in the service of the Prometheus Grafana, and we are going to actually change the cluster IP by a node port type of service. In this case, you can see how it already is a node port, because the K3S has just retrieved the service with everything, with all the resources. But here you should change the cluster IP by node port. So once this is done, we are ready to access to our Grafana dashboard. So in this case, what you can do to know the IP of your server is to use this ifconfig command. In this case, you can see how the IP that I'm using ends up with 188. So in this case, we would go to this IP, and we would be accessing to Grafana. In this case, I already was registered, but let me do the thing again. So we would be accessing to this IP, and then to know the node port, we actually can get all the services, and we are going to see that for the Prometheus Grafana service, we have to get the port that we are using. Remember that we changed the cluster IP by a node port, and we have to look for the port here, and we can see it that is in this line. So we just copy paste the port here in the browser, and you can see how we are already accessing. But the thing that I wanted to show you is to make a sign out and show you the credentials. So here I'm going to put the username, which is admin, and then the password I'm also going to copy it here so everybody can see it. Is prompt operator, and we are going to copy paste it here in the password. And sorry, there's a space here, and voila, we are inside. So the next thing that we have to do here is to download the dashboard of the node exporter. Here we are just going to download it also from Grafana. We have just to type this number. It's 1816. This is the identifier of the dashboard. So the thing that you have to do is to go to the dashboards and then to import, and import via grafana.com. You are just going to copy the number. You just put load. Here it is saying this to me because I already had done it in the past. Remember to put the Prometheus as the source of data. Remember, the Prometheus is the database. And here we can see the node exporter dashboard. You can see how the CPU is not very busy now. The system load is also not very busy. We are detecting here a possible problem with the file system, which is nearly full. But here you can see a lot of useful charts. For example, we can see across the time the memory usage. And what we can do is to actually change the time scale here and to show, for example, what has happened in the server the 2 days before now. Or we can increase it to 7 days. So here you will see that I already installed this Grafana chart 2 days ago, but not 7 days ago. So we are going to just go back to 2 days and here. And then you can see here more related information such as the CPU usage, and you also can see more metrics from the memory, and also, for example, about hardware, what is the temperature in the processors or the network traffic as well. You can see how there are some peaks over here. And basically, now we are completed with our tutorial. With this, we conclude everything that has to be covered in this tutorial. Now we have a couple of related videos, one for Argo CD, how to install Argo CD using a Helm chart, and the other one, how to use Kustomize, a very interesting tool about how to automate our builds also when we are deploying them on top of a Kubernetes distribution. Thanks to everybody for watching, and please don't forget to subscribe to my channel. Bye bye!